Welcome to Lecture 5, in which we will continue to consider some of the problems or exercises at the end of Chapter 2. And because it is so closely related to the exercise that we just considered, I'd like to next consider exercise 2.6. And I'm going to consider two parts of this exercise, but let me tell you the directions first. And just as a warning, since I suspect that perhaps not all of you have the book yet, I will continue for the next couple of lectures or so to write out the problem instructions in detail, but soon I will expect everybody to have access to the textbook, and then I will probably write the directions in a quite abbreviated form, because I will be expecting that you will have the book if you want the extra details. So this exercise has the following instructions. It says, for each pair consisting of a state and a measurement basis, describe the possible measurement outcomes and give the probability for each outcome. And let's first look at part A. The pair given there is the following. The state given is square root of 3 over 2 times the 0 ket minus 1/2 times the 1 ket, and the measurement basis is the 0 ket and the 1 ket. So this is actually a very easy problem. The possible measurement outcomes are simply the states in the measurement basis. So in other words, 0 and 1. Those are the possible outcomes that we can have when we perform this measurement with this measurement basis. And now we want to calculate the probability of each of those. Well, in order to do that, we need to take the state that is given, square root of 3 over 2 times 0 minus 1/2 times 1, and we need to express it as A times the first vector in the measurement basis plus B times the second vector in the measurement basis. And if we do this, then the probability of measurement outcome 0, the two outcomes again are 0 and 1, so the probability of this outcome will be the magnitude squared of the coefficient of that term, and likewise the probability of this measurement outcome is the magnitude squared of this coefficient. Let me just write that out. So probability measuring zero is A times A conjugate, and the probability of measuring 1 is B times B conjugate. So the only work that remains to be done really is to find A and B, and in this case that's trivial. We see right away that this statement right here, that the square root of 3 over 2 times the 0 vector minus 1/2 times the 1 vector is equal to A times 0 plus B times 1, that implies that A must be equal to the square root of 3 over 2, and B must be equal to minus 1/2. No other values will do, and if you want to prove that, simply first take the inner product of each side of this equation with the 0 vector, and when you do that, this term will drop out, this term will drop out, and the reason those terms will drop out is the inner product of 0 with 1 is 0, and then when you take the inner product of 0 with 0, you get 1, so you'll get square root of 3 over 2 on this side, and likewise when you take the inner product of this with 0, again, inner product of 0 with 0 is 1, and 1 times A is A, so we get simply square root of 3 over 2 is equal to A, which is what we have here. And likewise, if we take the inner product of both sides of this equation with 1, this will disappear, and this will disappear. The inner product of 1 with 1 will be 1. The inner product of 1 with 1 will be 1 here as well. And so we get minus 1/2 is equal to B. So we have this. And so now we can immediately calculate the requested probabilities. We have square root of 3 over 2 times square root of 3 over 2 conjugate, and since square root of 3 over 2 is a real number, then this is just square root of 3 over 2 times the square root of 3 over 2, which is 3/4. And likewise, for the second probability, we have minus 1/2 times minus 1/2 conjugate, which is minus 1/2 times minus 1/2, which is 1/4. And so here are the probabilities for this problem. And one more thing we'll note is that the total probability here, probability of measuring 0 plus the probability of measuring 1 is 3/4 plus 1/4, which is 1, as we would expect. So it's a certainty that the measurement will yield one of those two results. So this is a very easy problem, really, to do this. And so now let's jump to a slightly more complicated example of the same procedure and see how you can do this. So in the very last part of this exercise, in part G, the state is the plus ket, and the measurement basis is 1/2 times the 0 ket plus square root of 3 over 2 times the 1 ket. That's the first term of the measurement basis, and the second one is square root of 3 over 2 times the 0 ket minus 1/2 times the 1 ket. And so again, we're asked to identify the possible measurement outcomes and then to calculate the probability of each. And just as before, the possible measurement outcomes actually, let me stop because, as I said, this problem is just like the one we've just done, Part A. So I very strongly encourage you to stop the video at this point and try to work this problem completely on your own now from beginning to end. And then when you think you have the answer, turn the video back on and check your work. So stop now. Okay, well, I hope you had good luck in trying to do this problem. So let's now work it all together. As I was saying, as was the case with Part A, again here in Part G, the possible measurement outcomes are simply the terms in the measurement basis. So one outcome would be 1/2 times the 0 cat plus square root of 3 over 2 times the 1 cat, and the other possible outcome would be square root of 3 over 2 times the 0 cat minus 1/2 times the 1 cat. And as will be the case in all of the bases that we will be working with, this is an orthonormal basis. In other words, if you take this term right here and take its inner product with itself, you will get 1. Likewise, if you take this term and take its inner product with itself, you will get 1. And finally, if you take the inner product of this term with this term, you will get 0, meaning that the two terms are orthogonal to each other. So that makes it easy for us to do the next part of this, which is to find the probability of each one of the measurement outcomes. And just as before, what we'll do is the following. We'll take the state that we are given and we will express it as A times the first term in the measurement basis. So this will be 1/2 0 plus square root of 3 over 2 is 1 plus B times square root of 3 over 2 0 minus 1/2 1. And then if we can find A and B, which in fact will be easy, then the probability of measuring this outcome is A times A conjugate, and the probability of measuring this outcome is B times B conjugate. And so the way that we do this, again, remember that what's so nice about having an orthonormal basis is that expanding vectors in terms of an orthonormal basis is very simple. And so what we will do, you can think about it in the following way. This is an orthonormal basis. So we can think of this as some ket V, and this as V orthogonal. And if we do that, then we see that A is equal to the inner product of V with the given state, and B is the inner product of V orthogonal with the given state. And the way that you can see that is simply take the inner product here of each side of this equation with v. And so on the left-hand side, you'll get the inner product of v with the plus. And on the right-hand side, this will go away since v and v are orthogonal. And this is equal to 1 since v is a normal vector, so inner product of v with itself is 1. So we get a, so we get the first equation. And likewise, if we take the inner product of both sides with v orthogonal, we will get this equation. So all that remains now is just to evaluate these expressions for a and b. Now, if you will refer to page 22, you will see that the definition of the plus ket is the following. Therefore, we can write A in the following way. Let's perhaps do it like this. We'll have 1 over square root of 2 and again, this equation that we've just written comes from substituting in for this plus ket, we have substituted in this to obtain this. And similarly for b, we will get 1 over square root of 2 the orthogonal 0 plus 1 over square root of 2 times the inner product of the orthogonal with 1. Okay? And now to evaluate these expressions, all we need to do is refer up here to this equation for the identity of v and v orthogonal, and we'll be done. So when we think of substituting v into this equation for a, when we substitute it in the first one, this second part is irrelevant because the inner product of 1 with 0 is 0, and so we'll simply pick up a 1/2. So we get 1 over square root of 2 times 1/2. And then for the second term, when we take the inner product with 1, the first term will drop out, and then we have this, so square root of 3 over 2. When we do the same thing over here for in the equation for b, we get 1 over square root of 2, and then for the inner product of v orthogonal with 0, you can see from this equation we will get square root of 3 over 2. And then for here, the inner product of v orthogonal with 1, you can see with here that when we take the inner product of this with 1, we'll get minus 1/2. And therefore, we're now able to say that a is equal to 1 over 2 times the square root of 2 plus the square root of 3 over 2 times the square root of 2. So this is the square root of 3 plus 1 divided by 2 times the square root of 2. And if we multiply top and bottom by square root of 2, this will give us square root of 6 plus square root of 2 over 4. So A is equal to the square root of 6 plus the square root of 2 over 4. And for B, we will get the square root of 3 over 2 times the square root of 2 minus 1 over 2 times the square root of 2, which is square root of 3 minus 1 over 2 times square root of 2, and then again multiply top and bottom by square root of 2, we will get the square root of 6 minus square root of 2 over 4. So B is equal to square root of 6 minus square root of 2 over 4. So now the probability of measurement outcome we'll look at the first one. 1/2 times the 0 cat plus square root of 3 over 2 times the 1 cat. Well, that will be A times A conjugate, which is square root of 6 plus square root of 2 over 4 times square root of 6 plus square root of 2 over 4 and that will be equal, we square the first term, that will give us 6, and square the second term will give us 2, so that's 8, and then multiply the first times the second and double it, so we have 8 plus 2 times the square root of 12 over 16, which could be written as 8 plus 4 times the square root of 3 over 16, which is 1/2 plus the square root of 3 over 4. And the probability of measurement outcome square root of 3 over 2, 0 minus 1/2 1. Well, that will be B times B conjugate, which is square root of 6 minus 2 over 4 times the square root of 6 minus 2 over 4. Oh, it's square root of 2, sorry. And so again, square the first term, you get 6. Square the second term, you get 2, so that'll be 8 minus 2 times the square root of 12 over 16. And so that's going to end up being 1/2 minus square root of 3 over 4. And that is those are our answers. And notice that once again, just as before, and just as we expect, these two probabilities here add up to 1, because certainly we must measure one of these two. So if we take probability of the first one plus probability of the second one, we must get a total probability of 1. So that completes all that I want to do with exercise 2.6, and I think that you should now be able, I think that you will be able to easily do an exercise like that on your own. So let's go ahead now and talk about problems for this lecture. So the problems for lecture 5 will be the following. In each case, what we want to know is we're dealing with a state 1 over square root of 2, 0 plus 1 over square root of 2, 1. Same here, 1 over square root of 2, 0, 1 over square root of 2, 1. Same here, 1 over square root of 2, 0, 1 over square root of 2, 1. The only way in which these problems differ is the following. In the first one, you're asked, what is the probability of measuring that state as 1 over square root of 2, 0 plus 1 over square root of 2, 1? What is the probability of measuring it as 1 over square root of 2, 0 minus 1 over square root of 2, 1? And what is the probability of measuring it as square root as the 0 kept? So you have 3 different measurement outcomes. What is the probability of each of those measurement outcomes if the state being measured is 1 over square root of 2, 0 plus 1 over square root of 2, 1? And in each case, circle the correct answer, or if you think there are multiple answers, then select all the correct answers. So that concludes lecture 5, and good luck.